Welcome to Chatting with Chuck. I'm your host, Chuck. Today I'm welcoming back Ken Kao. He is the Director of Product Sales Management at B&B SmartWorks. And we're going to talk about Industrial Ethernet versus Standard Ethernet. And Ken, what's the key benefit of Industrial Ethernet versus Standard Ethernet?
Sure. I'm happy to share a little bit idea regarding for what's the difference between the Standard Ethernet and the Industrial Ethernet. So majority for the Industrial Ethernet, majority to design for the industrial application, like for the oil and gas environment, factory automation, power station, and the transportation. And especially the product design for the harsh environment in order to compensate a lot of the harsh environment, including the operating temperature, including the safety, and especially this kind of product will connect into like a field local PLC controller or robot in the factory floor. They will connect into the traffic controller in the transportation environment. So the entire environment is not really like a data center. You have the air conditioning pretty much in the field cabinet, and no fan, no air conditioning, and no everybody daily to check in to check out the environment status. So that's just the entire factor we kind of come out for the Industrial Ethernet design, because we trying to survive and have the people have the product sustain this kind of environment. And then a couple three major key concern the entire product design for. The one is about the product reliability. The second one is about the safety. Third one is about the product longevity and the service. Let's talk about the first one, about the reliability. When we talk about reliability, definitely here's the couple factor we care about that. The first one is about the environment. When we talk about the environment, you will involve regarding for individual different vertical market, including the transportation, factory automation. That could be the totally different environment. So from the product design standpoint, we design the product fitting into the different environment. Could be high temperature, could be low temperature. And the other point is about the case and the connector and the mounting, because the most of the time when we dealing with the factory automation, the people majority using the DIMM rail mount. They are not using the desktop just sitting there. They put on the DIMM rail kit and to fix more solid and put into the traffic cabinet. Not traffic cabinet, it's a control cabinet. But for the transportation, when the people put on the product into the rail train, they have certified for the anti-vibration, anti-shock vibration, etc. So the entire connector we will design for the M12 connector is the waterproof and super reliable to make sure all the connection physically they can be pretty reliable. For the power supply, we're using the DC power input. We are not using the commercial grade for the AC adapter, because the DC power input got the lower power voltage and they got more clean, way more clean than the AC power input. So the power still is majority big different compared with the Standard Ethernet and the Industrial Ethernet. And the last one is about the NTBF. We call the mean time between failure. This is the majority down to the component design inside the product. For the industrial product, we specially select longevity component and especially qualify for the high criteria component put into our product. So the entire mean time between failure, our number is at least is over 10 years. When you're running in the field, at least you can easily run in the 10 years. It's no problem. So this is about the first point. We talk about reliability to cover the couple environment, connector, including the power, including the mean time between failure. This is about we concern about reliability. The second one is we talk about the safety. So when we talk about the safety, we were talking about the different vertical. They have the different safety requirement, including like a hazardous location, anti-vibration, like I just mentioned for the transportation in the railway industry. The people care about the anti-vibration and the anti-shock kind of situation. We talk about the product drop and to dealing with the more sophisticated the certification running. We talk about the certification side. So that's all certification design. It really depends on the individual vertical market to design for that. And the last one is we talk about the longevity and service, because for the product, for the industrial environment, the people cannot always every year to change the design. And pretty much when they design into the one product, they're looking for next 5 years, 10 years, they don't want to change because the whole system certification will cost a lot of money. So longevity product support and the offering, that's always the biggest concern in the industrial application, especially for machine builder, for the industrial automation, they really cannot always change regarding for the design. So I would say that's about a recap about 3 major difference, and we design for the major factor is about reliability, safety, and the longevity and service. That's all about we kind of design a product, put into the one box, and then provide the majority benefit for the industrial Ethernet.
Great, Ken. Great explanation. Tell me, what's this real-time Ethernet?
Yeah, I didn't address a lot of the real-time Ethernet, but the real-time Ethernet is part of the pretty important fact in the industrial Ethernet. So when we talk about real-time Ethernet, we're more talking about a deterministic capability, especially when you're running the robot, running for the PLC. That's just the majority, the people and the application that really need the lower latency time because they cannot accept any latency between the communication. So when we design for the real-time Ethernet, we especially build in for Ethernet IP and the Profinet. Especially for Profinet, you can separate the 3 major categories. And our product majority to comply the class 2, we call RT, is majority for the real-time. So the entire latency time is less than 20 milliseconds. If you're talking about a standard Ethernet, they're looking for the latency time of a second. It's not talking about a millisecond. Definitely, if you're talking about a super real time, that will be the microsecond. That's just will be the different category. But our switch application, our communication for the layer 2 application, we are majority to focus on the real time, majority for the 20 milliseconds, especially for the Profinet.
Great, Ken. What about industrial certification?
Okay, so we talk about certification. I highlight for the second point we design for into a product. It's about the safety. So when we talk about the certification and the safety, that's related into the different vertical market. Take example for the oil and gas. Most of the people, they care about a hazardous location because they will care about which location your product installed nearby fire, and they will define for the different safety level. So the most of our product, because we install into the control cabinet, is not really in the field close with fire. So for the hazardous location, we specially certify ULC Class 1 Division 2, ATEX Zone 2, and IEC-X. This is majority designed for the hazardous location. And we also have the product to certify EM5155 designed for the railway application for the onboard communication system. So EM5155 addresses a lot of the criteria, but the most criteria is about the anti-vibration and the shock, because in the railway application, there is no certain area is kind of not like a comfort environment. It's really rough environment. So EM5155 to define all the way from the anti-vibration to the electrical, magnetic, including for the product design. That's whole the specification they design for the EM5155. And the last one is about, we talk about the control cabinet. UL508 is basically it's the standard for the control cabinet. So the most of the time, the people, when they put into any device into the control cabinet, they need to certify the entire UL508 in order to put your component into the control cabinet. Then the entire system will comply for the safety consideration for the UL. So that's just about the industrial certification for this.
Great, Ken. I think people would like to know in what areas makes the big difference between industrial Ethernet and standard Ethernet.
Sure. So I highlighted a couple points, but let me summarize the majority key point between the commercial Ethernet and the industrial Ethernet. The first one is about the operation temperature. So the most of the commercial temperature, they only can sustain the 0 to 50 degrees C, and but the industrial product design, we're starting from the minus 40 to the 75 degrees C. That's just really can sustain the wider operating temperature, especially you don't need to put down the air conditioning in your environment. That's just the biggest difference for the operating temperature. The second one is the power input. Like I say, for the commercial one, they're pretty much using the AC adapter power input. But industrial grade, we're using the DC, low power voltage DC input, and way more clean and not much noise. That's the major come from the DC for the power input. Also consider the reliability for the NDPF. For the commercial, majority sustain around 5 to 10 years, but for the industrial, at least we can sustain 10, 20 years easy, because down to the component design, we choose the higher quality and the higher criteria product for the component designed to the product. And including the redundancy, I didn't address about the redundancy at the beginning, but the redundancy is a part of a pretty important fact for the industrial application, because if you're thinking about robot application or production line, if your communication go down, then you probably lose a lot of money because your machine shut down there and you are not able to use the product as you're scheduling. So the redundancy is always kind of help the entire application reduce the entire downtime. So the application for the industrial Ethernet, we specially designed for the real-time redundancy. We can cover recover time around less than 20 milliseconds. Like we talk about the real-time Ethernet, that's also the part of the redundancy we're talking about. And the last one is definitely about certification. Like I say, for the commercial one, they are not really designed for the specific application, but industrial product does support a specific application, like oil and gas, transportation, automation, etc. That's the majority we design, and we kind of focus on regarding for vertical market to design the requirement to fit into the specs. So this is about the wrap up regarding for majority difference between the commercial Ethernet and the industrial Ethernet. I hope this is kind of clear for you, John.
Great. Yeah, thanks, Ken. I really appreciate you taking the time to give us a little insight on industrial Ethernet versus standard Ethernet. This has been Chuck with Chatting with Chuck.